Slides prepared for this event, but I have some from a past talk that I can use to kind of kick off the discussion, and I think that's more the framing, is just to have like a conversation with the people here in this room. But yeah, I can like tell you a bit about like the state of things now on Ethereum with MedBoost and PBS and things like that. And yeah, then maybe that will seed off the conversation and we can go from there. So yeah, I guess one question is just like, has everyone here heard of MedBoost? Does this mean anything? Yeah, okay, there's like maybe a few nods. So anyway, maybe I'll just start from the beginning then. So we have Ethereum. We all know and love Ethereum, and Ethereum's cool because it lets you send transactions, which can do all sorts of types of things with all these decentralized applications. It turns out that you can basically, craft the blocks of Ethereum in a certain way, and in this certain way, it turns out that like a builder of the block can get more, revenue or profit compared to other ways. We generally call this thing MEV. And point being is this poses a concern for the protocol because, essentially if you're better at MEV extraction than someone else, then you now kind of have this flywheel where you can reinvest in your operations and you just get bigger and bigger. What this could even look like right now is offering better returns to validators, and then you have this flywheel where like all the stake ends up with you and Ethereum is no longer decentralized. So this is very bad. And I think the way we generally think about this, in terms of at least protocol research, is with PBS. PBS here is proposer builder separation, and it's thinking about ways to separate off this building role of these like very valuable execution payloads in the protocol from these validators, right? So what you could imagine is there's this like very even light layer of validators that are again sort of attesting to the validity of the network, but then you entirely firewall off these concerns of this MEV stuff. And the point here is that even if you do end up with like a very centralized builder or block builder world, I mean, even nowadays we talk about like a transaction supply chain, so it's like very much professionalizing and like operationalizing. Even if that does, become more centralized than we would like, you still have this like very robust validator set that attests to like the truth of the chain. So, is there a question? Oh, sorry. I'll keep going. So what else is there to say? So PBS, right, I guess from PBS then, there's a question of, I just killed it. What happened? Oh, my computer went to sleep, sorry. So from PBS, there's a question of, how would you actually implement this? And there's a lot of ways to think about it. You can either do it, I guess like one high decision point is like, is your PBS on-chain or off-chain? And we'll talk about on-chain flavors in a bit. But given that, like an on-chain setting would be a protocol change, it's probably going to take a while to even come to an agreement around what the best way to do this. And even right now, maybe I'll talk about this in a little bit, but even right now, there's still like big open questions around the best way to do PBS in the protocol. So what can do? Well, in the meantime, we can essentially do PBS off-chain, and the implementation we have that has the most adoption at this point in time is MedBoost. And I think that'll tee me up for these slides. So the way you can think about this working is that it's almost this like rendezvous service between, again, builders and proposers. So these proposers, as you go to like validate the chain as a validator, you then also have the opportunity every so often to propose a block. This is building like the consensus block, and then also this execution payload. And now this is where the PBS comes in, is you can think about carving off the task of building this execution payload, the execution part of the block where all this like juicy MEV is, and handing it off to like someone else. And MedBoost, again, is a software stack and a protocol that implements this. And one way to think about it is, you have this like, this green sort of rectangle over here is like the execution payload. The gold is meant to like represent the MEV around it because it's like this nice money everyone likes to fight over. And then you have this blue block on the right, and this is the consensus block that the proposer wants to, send to the network. And the question now is like, how do you have like this, secure exchange between these two parties who might not trust each other, and in fact we don't want them to trust each other, because otherwise, again, you kind of fall back to the status quo I was talking about, or not the status quo, but a failure mode that I was talking about a minute ago, where you have like a very small validator set that all works with these like one or two builders and things like this. So in any case, we now have to think about how to get this block, the execution payload, into the block and make this all work well. And at a high level, the way to think about MedBoost today is that it's like this commit reveal protocol, meaning you like commit to something, and then once you've committed to it, the person committing now is the proposer, but once they've committed to it, then the builder is free to like release their block with no worries. And diagrammatically, you can imagine that the builder then has their like nice green execution payload. It has like some juicy MEV with a gold border, and then the like shaded thing on top of it is meant to represent that it's blinded. And the reason why you want this is because if the builder sent the payload in clear, then the proposer basically could like copy the builder's work, take all the sort of rewards from that work for themselves, and the builder would be unhappy. What this means then is that the mechanism itself is not sound, and then no one would use it, and it would be bad, because proposers would just fall back to like these backroom deals and God knows what. So the way to get around this is basically you need some way for the proposer to commit to the block. This is the commit step, and so they get a blinded payload which goes into the block. The way this works is that, sort of like zooming way into the details, the proposer signs over this block in a compatible way with what's actually the thing that ends up on chain. And basically they do this, and then they can show the builder kind of as proof that like they've committed to this particular payload, say including one that pays the builder for their work. And then once the builder sees that, they can release it to the wild, and this bottom right square is what would go on chain. And so the thing to consider here is like this sort of MEV stealing issue that I was just trying to describe. Like you can imagine that there's a block with some MEV, the builder takes like some amount of funds to that address and wants to pay the proposer this. If there isn't this like commit to reveal step baked into the protocol, then the proposer basically could just take the block, say thank you very much for all this hard work. They could rewrite the payment transaction, for example, that sends all the revenue to the proposer, and then builders don't want to use it. There's no builders, no proposers use it, and again, we don't have some sort of PBS to protect the validator set from pressures of centralization. So that's bad. Okay, so that's like kind of a very high level review of like PBS today, off-chain, and how it works. And so this has been live basically since the merge, so for a few years now, and at this point, it's like an even more complicated picture in this because now there's like solvers and like bundlers with 4327, and like every day, new parties come online that are part of this like transaction supply chain. But all being said, just to give you a sense of like what this looks like right now, you'd have the validator here that's labeled. They use MedBoost to talk to these different relays, which I'll talk about more in a second. The relays then interact with builders, and you have this. So I called out this relay actor. This one's like very important and pretty much the source of all of our problems with this system today. The relay basically acts as like a trusted broker between proposers and builders. Otherwise, there's not like a nice way to like trustlessly have this exchange that I just laid out with this commit reveal protocol. And because of that, you need the relay. The relays exist. What this does, it adds like another intermediary into things that can have its own issues, whether that's being a single point of failure or especially with concerns of censorship. And these things also have bugs and like can go down, and there's just a bunch of headaches that come out of this. But this is what we have today. And if you follow the space at all, you've heard about these relays, I'm sure. So again, like the system shipped around the merge, and again, these numbers are a little dated, but what I can probably do is even just go here right now. Here we go. And you can see that they should look about the same. So you can see here like there's over 90% of blocks, say in the last 2 weeks, have gone through the system. So people like it, people use it. Again, it like adds extra MEV, extra revenue to your block. For example, you could say the average payment here is like 0.05, but I think we'll see a bit later there are like very there are payments that are very much outliers, and they sometimes pay quite a bit. One thing you can see here is that there are like 12 relays and 31 builders registered, or at least like observed, which is like pretty nice for decentralization purposes. I think I'll touch on in a second that the picture is not so great once you get into actual details. So anyway, point being, people use MedBoost, and it's what we have today, and it works, which is cool. However, there are some downsides. The downsides here are that censorship, especially at this like relay actor I was talking about, like quickly entered the chat, meaning like within, pretty soon after like the launch of this system, it became clear that like relays and builders would be censoring certain transactions, and this like directly harms Ethereum's values, which is not good. Again, I can actually go grab the web page here to see the latest data. I know it's improved a bit since here, but in any case, people were very concerned about this and still are, right? I mean, it could be the case that like new relays enter the market that get a lot of adoption and they start censoring, and again, we have the same problem. Yeah, so maybe if this isn't self-explanatory, basically it's saying that, right, basically this like red blob is like censoring, the green are not, and yeah, let's actually go check, because it's right here. So that's over the last day. We'll get this nice graph. Right, so you can see here, okay, I mean, this doesn't look great. Point being is that, yeah, I mean, censorship is still very much a problem. And yeah, so we want to think about ways to improve it. Another thing that's maybe not quite, well, I think there's like 2 points here. So like one point here is that, there's not just a censorship issue with relays. There's also very much a concern of, yeah, the system not being secure, right? So just in terms of like, this is software running around the world, there can be bugs, accidents happen. Sometimes they're harmless accidents, or at least like not malicious. Say a relay goes down. What this would likely mean, especially in the Mabuse context, is if like the relay can't get the final block out in time, then like the slot's basically missed. The logic here is that the proposer has already committed to a particular block. They want to essentially buy from the builder, and if the relay can't, facilitate the whole auction or exchange, then the proposer's just out of luck, and then we miss a slot in the protocol, right? So sure, it's maybe just one slot, but generally this is bad. So there's like some security things which I think already are like make people uncomfortable with relays, and that being said, there can even be malicious attacks, right? And so again, if you follow the space, you've heard about this one, the Low Carb Crusader. What did I want to call out here? I think, right. So I think the point here with the callouts is that this was an incredibly profitable attack. I don't know how many people are familiar with this, but basically what happened was there was a bug in the relay implementation at the time where, as a validator, you could basically trick the relay into giving you the block without having to commit to it. And so that's exactly what these attackers did. And they also did a bunch of other very clever things to then also in turn mess with the transactions in the payload. If you've heard of like searchers in this context, there are people who are like making different trades to like arb, say Uniswap, or different token pools. And yeah, they even like went as so far as like bait the searchers who were trading and then basically sandwich the sandwichers, if that makes sense. And anyways, it was actually it's a very fascinating attack, and I would recommend reading up on it. But that being said, this is very bad. So yeah, again, we just see more and more cases where relays are causing problems, and it'd be nice to get rid of them. So, well, okay, before I get to here, maybe like another sort of new update since I made these slides is like also the question of like relay sustainability. And this is actually quite a big one because, again, over 90% of blocks are coming through the system. There are effectively like a very small number of relays. I know that the Mobus.pix website showed a lot more, but in terms of market share, it's really a small number. And I may actually, yeah, so let's do this just to make the point. Right, so these are looking at relays, and you can see here, so this is basically breaking them down by market share, and really just, you can look at the pie chart on the right. So we see basically, yeah, there are like a number here, but Flashbots only has 5% as a relay, and then otherwise you have Blocks Route, which is here. Then you have another Blocks Route relay, and then Ultrasound. So honestly, there's like 3 relays that have pretty much dominated the market. And really, this one is like honestly just one relay. So yeah, that's not ideal. We can do the same thing for builders if this loads. Okay, yeah, so If anything, this looks even worse. Again, so the left and right here, the left one is just also including like non-MedBoost blocks. So for the purposes of now, you can kind of just ignore it. On the right here, you see for all MedBoost blocks, who's responsible for what, and you really see it's just these two builders here, right? This is very bad. I will say these two builders are like, quote, aligned a lot more than like random builders could be. But again, you could imagine a much more unaligned actor comes to the table in the next year or two, say like one of these more like traditional like institutions, like these big trading firms, and they could just dominate and care even less about like Ethereum's values and things like this. And maybe just to give you another view on this, you can go to Etherscan these days, and then you can see like it gives you the miner, but really they just mean like the builder here. And yeah, it's like Beaver, Titan, okay, someone from Lido, this one's fine, Titan, it keeps going. Beaver, Titan, like, it's really not like a great picture. So, if anything, there's now like two levels of concern here. There's like relay decentralization and also builder decentralization. And people think about both these parts of the stack. And yeah, there honestly just aren't like any silver bullets yet because it's actually like quite hairy once you get into it. But yeah, so given all of this, you might even be wondering why we did this in the first place, because it sounds like it's actually pretty bad. And, I won't lie, it's not great. But that being said, now the question is, well, okay, are there things we can start to do via the protocol that would remove some of these trust assumptions? Are there like other protocol features that would play into this? Like you could imagine that we have builders, but then they are subject to like inclusion list or something like this. And that might fix the censorship problem. So there's like a lot of things we could think about. And the question then is just what? And once you get into this rabbit hole of EPBS, you find it like is perhaps infinitely deep. I don't think anyone's found the bottom yet. There's like a number of different flavors of design. There's many different concerns across the design. They touch all parts of the protocol from like fork choice to block production to the incentives around making blocks and attesting to blocks. And yeah, it's like a very core part of the protocol, and it touches a lot of things. One thing we could start to do is get rid of this relay. And the way to think about this is like you can imagine the relay itself becomes the protocol. Somehow like, yeah, this protocol is now going to like be this like broker between builders and proposers, and you want to do this in like a safe way. There was this bit about optimistic relay. We can talk about this if you guys are curious. I think I'm going to skip this for now, but it just is referring to a mode of operation of the relays today. And yeah, this might be more interesting to think about for today. Essentially, like, yeah, flavors of EPBS. So we called out here EPBS PTC. There's this payload timeliness committee, and essentially, yeah, there's now an EIP for this, EIP 7732. That is a proposal to implement this design. The way to think about it is, yeah, you just kind of remove the relay, and now effectively the protocol acts as a relay in some sense. A key bit here is you need to have like trustless builder payments, because otherwise, again, you could imagine the proposer, like I was telling you a few slides ago, the proposer could just steal the builder's work. And so the protocol will work in a way that you basically have this money locked up, and then it could be used to pay it out regardless of what the builder does or doesn't do, or the proposer does or doesn't do. So that's pretty cool. And what else do I want to say about PTC at the moment? Yeah, I mean, an interesting part of the design lately is that you could even imagine like the builders and proposers directly talk to each other. Because again, the way the protocol works is you get a lot more of these like assurances in the protocol itself. And so then, yeah, you can very much imagine relays going away. That being said, there are a number of things relays I think still would even do in this world around either providing essentially low latency as a service or like a number of other like nice to have features, like cancellations are another one, and there's more we can probably think of. So yeah, I think it's very much an open question to what extent this particular design is actually going to like solve this pain point of the relay. And yeah, so this now, I think that might be everything that I want to call out at the moment. This is some stuff, yeah, I mean, there's always an infinite buffet of things to talk about. But yeah, maybe I'll just throw up this slide, which is kind of nice. And yeah, so I guess from here, maybe we can open it up. I don't know if anyone has questions or concerns, anything they'd like to discuss. You could even come up here and grab a mic. Okay, I don't know how to access the Q&A. Is it in some chat somewhere? Oh, here we go. Here, there's questions up here. Okay, so removing relayers. Each validator will have to discover and manage the builders they connect to. Will it just not cause disconnect to the two biggest ones and forget about it, entrenching them? Yeah, so again, I think there's like a number of questions here around this, and let me grab a sip. So maybe to add some context, this question is thinking about the latest EPBS design that I mentioned with EIP 7732. And the idea here is it's perhaps even pitched as like a benefit of this EIP that you don't need the relays because again, the protocol handles all the like trusted bits for you, and so then a proposer can just directly connect to the builder. One issue I think you could immediately see with this is just like privacy considerations. So now the problem is that, you know, if I have my validator, let's say I'm even just like a home staker and I don't have a sophisticated way to like obfuscate all of this. If I just connect to a builder, then like they have my IP and they can start doing bad things, possibly. For example, if it's they have my IP, they now have a target to like DOS, and so you could basically just like get a list of these things and just wait until someone comes up that you want to DOS. And then what this would look like is suddenly the chain goes down. So that's not great. This question then is in that context asking, right, in a 7732 world, if you get rid of them in this way and just, yeah, have validators connect to the people they want to, right, would you basically just have like the same entrenchment going on? So I think this is another good point. I mean, that I agree with. I mean, just I guess to be transparent, I'm not like sold on 7732, but that being said, the concern here is that, yeah, even today it's really hard to get new validators to connect, or maybe I'll frame it this way, it's really hard for new relays to get adoption by validators. Like it's almost this BD effort for them to go out and like track down all these validators, because again, it's like Ethereum is actually decentralized, so like it's very hard to even like know who to talk to like let them know you exist. And so because of that, yeah, you could see this sort of effect where even if we have this world, like validators still may just go to like the names they know simply because that's what they've been doing. And yeah, I mean, if anything, I think there's some good parts of 732, but I do have some concerns around, yeah, especially this point of like removing the relay. I think it might provide an opportunity for relays to be used less, but I don't think they'll go away. And yeah, that is what it is. Thank you. So next question. In early discussion of max EB, it was said that collapsing the set was a prerequisite for EPBS and SSF. Is that still considered to be the case? I'm not sure about EPBS. I mean, yeah, if someone else in the audience can think of something, we're all ears. I don't think so much about EPBS, but definitely so SSF. So SSF, again, is maybe a bit off topic, but the idea is basically, like right now, the way the protocol works is there's a notion of finality once enough validators have essentially voted on like a block in the chain. And right now, again, because we want Ethereum to be decentralized, we have the protocol designed in a way where like many validators can come to the table. This is kind of at odds with like getting this like a very fast finality because they need time to basically share their messages and run the protocol and all agree. And SSF is short for like single slot finality. And again, it's like a research direction that wants to say, okay, can we like, again, have finality in a single slot rather than like the current protocol of say like an epoch or so. And yeah, so in this case, so MaxEB, sorry, there's like a lot of context here. So MaxEB, this is an EIP, I believe it's 7251 coming into Pectra, the next hard fork. And basically this does like a number of things, but one thing it does do is allow a validator to be represented with like much higher stake. And so what that means is today in the protocol, beam chain question, interesting. In the protocol, you basically have every validator that has like a fixed stake is the way to think about it. They all kind of look the same. And this was done because it's much easier to reason about, especially like a large number of validators, if they all kind of look the same and there's no like special, you know, jewelry hanging off of any of them. But this also kind of artificially inflates the validator set and is at odds with things like SSF. So it would be much nicer for, even if you are still a single entity, say you come with like, more than 32 ETH, it's nice to just go ahead and like have that in the protocol be represented as one validator versus like, say you have 64 ETH, rather than 2 validators, you can now be 1. All that is to say that now with this feature, there's another part of this that lets you consolidate validators, and then you start to see how we get to fewer validators in the protocol. It makes SSF easier for like some other technical reasons, and we're off to the races. So cool. I guess I'll go to this next question. Thoughts? Let me go to the next question. Simple Q. What happens internally within relays? Do they just relay the best block? Okay, so relays do a lot. This is actually a fun question. So relays do a lot, and if anything, they keep doing more and more over time. So one way to think about relays is that, okay, so they're running an auction, and it's kind of this like two-sided marketplace is the way to think about it, again, between proposers and builders. And maybe just kind of walking sequentially through the flow, the way you could think about this is that builders build blocks. They also need to be watching the chain to know like the latest head, to know like what the next valid block could be. But on top of that, they don't just want the next valid block, they want the next valid most valuable block. So they do their thing, sourcing order flow from various places to make a very sophisticated block that pays them a lot of money. And so builders are doing their things. They eventually at some point in time have a payload. There's sort of like there's a spec, but if anything, there's like an implicit agreement that relays support very like a specific sets of ways to like have builders pay proposers. And so then the builder makes the block out of whatever revenue they happen to find. They then make a payment in a particular way, which usually, a way to think about this is they just staple a final transaction on that pays the proposer some amount. That amount then is basically their bid in the auction for that slot. So then the builder submits the block to the relay gets this, they then do a bunch of stuff. One thing they do is they take the block, they validate it locally, because a builder, again, builders are, it's like an open set of builders as well. A builder could just like be spamming a relay with like garbage. So they have to validate the block. They validate the block with respect to the protocol, but then also this like sort of subset property that it sort of follows, again, this like PBS protocol of MapBoost. And so a key thing here is like this payment, that the proposer actually receives some payment. So they do all that. Then from there, they can extract out what looks like to the proposer as a bid. The bid says like some metadata about the block, maybe like the block header, and then also the value. Question?
How does the builder know the address of the proposer? Yeah.
Right. So there's a step before all this, which is that as you start your node, let's say you're a validator, you start your validator, your CL and EL, also run MapBoost. When it does this, you tell your consensus client that you want to use this external network. And as part of that, then it basically sends these like registration messages to the relays you've configured via MapBoost. Right now, it actually happens like once an epoch or something, so like pretty frequently. But in that message, you say, hey, I'd like to register, like I'd like to be in your set of validators that builders could build for. And as part of that message, there's like a proposer payment address. So then separately, this is again why builders need to be watching the chain, because they need to see, say they have like an epoch of look ahead on who the next proposers are. When they say, oh, I want to build a block for, the millionth slot, they can go look and see ahead of time who the millionth proposer will be, and then they can go to the relay and get the payment address there, and that's who they pay. Yeah. Okay, so we're in the relay. They validated the builder side of things. They now have a bid, and the bids can be served, and there's like some APIs that MapBoost knows how to call. So then when it's time for the proposer to now sort of, let's say, accept a bid out of this set of bids, this is all time such that, again, because we registered, the CL knows to call the relays, at least it knows to call MapBoost. The way to think about MapBoost is like this little sidecar software that's essentially a multiplexer across multiple relays. And again, like you don't want to work with just one party. It would be nice to be able to work with like many of them, and in practice, that's what people do. So now the way it looks as a proposer is as you're about to propose for your slot, you're like, oh, hey, I want to use this external building service. So then, a little before my slot, I start talking to them, and then you call all the relays you configured. They then respond with these bids. So, on this other side of it, actually, maybe if I had a whiteboard, this would be easier. But anyways, just follow along. So if we got to this place where builders are putting blocks into the auction, relays are exposing bids. The proposer then via MapBoost is calling multiple relays for bids. They now have like a pile of bids, and they can pick whatever they want. I mean, the way the protocol works right now is that they pick the highest bid because, we assume people want to be maxing revenue. So then out of the set of all bids you get for your slot, say you pick the highest one. From there, we get to this like commit reveal game that I was talking about, where as part of the bid, the validator has the block header that can go in a compatible way into their consensus block. They can then sign that, and this is the same signature that would go on chain, so that's like a nice property that makes this work a lot better. Once the proposer has this signed message, that commits the proposer to this exact builder's payload. They send that to the relay. The relay then can validate that, and that's actually the bug I was talking about with the low carb crusader, that the relay at the time did not validate that signature correctly, which was a huge problem. It's been fixed now. But in any case, you validate the block, and then if it all looks good, you can really at that point, like, and relays do this as well, they should send the payload, like the builder's payload, to the proposer, but they really don't need to. Like at that point, the relay has all the data they need to make the next block in the chain, and they can just gossip it out. And you do both. Like relays gossip things, they send it back to the proposer, and they gossip it themselves as well. So, okay, that was a lot. The story keeps going. I don't know how much we want to get into this, but yeah, I would say that's like the basic flow, and then from here, even in like the last year and a half, we've seen more optimizations. I guess this is the next point to make, is that time is money. And what this means is that there's like, again, this like very sophisticated, pipeline or like supply chain of actors. And the way to think about this is because of the way MEV works, basically, every even like millisecond is like some money to some, in practice, these builders usually end up being like very sophisticated financial entities. They're like, are being like centralized exchanges against decentralized exchanges and all sorts of things like this. And in this case, like it very is much the case that, the market can move against you. And so suddenly like what you thought of the world is stale, and you basically want to be able to react to that. And what this means is like now this pipeline's become incredibly latency optimized. Like the top relays basically do like very, very aggressive latency optimizations. This can look like things like having builders co-locate with relays, which is also not good for like vertical integration reasons, but it is what it is. And yeah, then even from there, I mentioned this point of like relay sustainability. So right now, relays, well, let's say when the system launched, the claim was essentially relays would be public goods in the sense that they would just perform the service. I could think, well, I can say the concern was essentially that if you had a relay that basically could charge more than other people, then you still have the same sort of like centralizing flywheel that could play out. So in any case, I think there's like pros or cons to both models. We have sort of this public goods model, and that's a problem because it turns out public goods funding is really hard. And a lot of the relays I think are quite strained right now with respect to like sustainability. So one way relays have thought about this is like trying to monetize somehow. And there's even like more sophisticated ideas around, I mean, we can get into it if you want, but basically the way to think about it is if I'm a relay, I can look at other relays, because these are all public APIs. I can look at other relays. I can, based on the other relay, I can basically charge like the second price across the entire auction set, and then capture the delta and maybe share half with the builder, half with myself, but then now I have like some revenue coming in, and there's some like sustainability argument you can make off of that. That's going on. There's also this notion of timing games, which is like very concerning with respect to at least the protocol. And the way to think about this is, again, time is money, and you kind of have like a lot of room right now to play with when you actually release your block to the network. You should propose at the start of your slot. This is like the honest behavior, but you really have up until like this 4-second deadline where the rest of the validator set would sort of observe your block and attest to it. So there's quite a lot of play here, and you can be more or less aggressive with respect to like how much of that time you take up. again, because you're trying to maximize profit. So that's not great. But point being is like relays, I think, are even thinking about essentially offering this as a service where they would do all this optimization for you and basically just give you like the best block they can. So yeah, this was a short answer, short question with like a very long answer. They do a lot and they're doing more over time. And yeah, it's quite crazy. I'll go to the next question then. After I grab some water. I don't know if there are any questions from what I just said. That was like quite a lot. Okay, well, thanks for the questions. These are good. So let's see, moving right. Some builders have their own searchers or something. Right, what's the additional value? Okay. Yeah, so this is basically a question around like exclusive order flow. I think is sort of like the buzz phrase that you would hear about this. And yeah, like the idea here is that, you know, the way you should, the way at least that, you know, I would want this to work is that these are all like independent entities that, you know, maybe are in competition in some sense, because then that drives usually better decentralization. Then from there, they all have like say open APIs, like any of these services, these like auctions we're talking about and things, they should be like independent or like open in some sense, because then now it like lowers the playing field or lowers the barriers to entry to level the playing field. So it turns out though that if you deviate from this nice ideal model, you can make more money. And so this is what we see. You know, you can have, I mean, like, yeah, sort of like a very pathological instance you can imagine is like I'm like a big wallet, or you're like a big Telegram bot. So I have maybe already a lot of valuable order flow, and then from there I could even like sell it directly to some searcher, there's some builder, and then yeah, you end up with this like very sort of perhaps collusive arrangement in the world. And that's not great, but ultimately, yeah, it just turns out that like, yeah, with these types of like, let's say agreements, then yeah, you can usually make more money. I think this is like sort of in direct conflict with like what we want to see out of this part of the world, but that's what we have. It's very hard to like prevent these things in protocol or like with anything like that, but it is an interesting research question. So if you think about things, there could be some fancy mechanism design, there could be fancy cryptography. There are ways to think about this that I think start to remove the ability or even like desire for these sort of like backroom deals. What about moving from the English auction to the first price sealed auction? So yeah, I'll talk a bit about this. This was kind of what I was saying with this like relay sustainability sort of experiment that has been playing out. So the way to think about it sort of from the beginning was that builders would bid, you know, hopefully the true value of their block, but even already, again, these are all public endpoints, so like builders have like sort of a PvP mentality where they could look at other relays to figure out what other blocks there were, and they could try to have responsive strategies and you know, in light of that. So in any case, the idea is that I'm a builder. I like basically say, okay, you know, if this block pays me X, I'm going to pay like X minus epsilon to the proposer. I keep epsilon for myself. That's sort of like my tip for the service. And yeah, then you'd have this bid that goes into this auction. And this is what we mean when we say like English auction. Yeah, let me think about this. Right. So English auction here is referring to the fact that like the bids would keep going up. And I don't even know if I would say this is an English auction actually. If anything, I think we'd call it, yeah, maybe I don't understand the question, but I think what we would call this is a first price open auction. If there are any auction theorists, you can correct me. But in any case, what I think this is asking about is then moving from that setting where basically you're just bidding in the open and the bids are, yeah, just kind of, they can be whatever. But again, the key point is that whatever you bid is what you pay. There are fancier auction designs where maybe you have a set of bids from people who are like, you know, trying to like sell a good or something. And then you could imagine doing more sophisticated things to like score the outcome of like the whole set of bids. And this is now what this like first price versus second price is referring to, where again, there's a result in auction theory where if you have a set of bids, sort of like the best auction you can think of ever having is one where everyone just bids, and what you do is you basically charge the second price, because that's basically like the only thing you would have to pay, if that makes sense. And the reason you do this is because there's now like no strategies around like different bidding games you can play that become pathological and all this. So in any case, we now have this thing I was describing where some of the relays have experimented with having like, different ways to process the bids. And the idea with this one is that, okay, you have a relay who observes all other relays, and let's say like, the highest bid from some other relay is like X, and the builder then is bidding like X over 2. Let's see, how would this work? It's hard to describe out loud. So you only need let's see. It doesn't go the other way. So I think then it might be the case that you have the builder who is going to bid. Yeah, I'd have to think about this to give you a nice example. But the point is that if you have a builder locally who's overpaying, then there's no reason for them to overpay relative to someone else, because otherwise if they had not bid, then the next builder would have won and they would have paid much less. And so that's where you then get this like rebate function. Yeah, actually this might help if I can just draw this out. I think this works. I just need to scribble. So I think this will be clear. So like you can imagine there's like relay A and relay B. And so the idea then is like, builder 1 is going to bid X. Builder 2 is going to bid, I don't know, let's say 2X. And so the idea then is that, right, let me flip this, 3X. Okay, so the idea then is that if you had this setup where the builder here is going to pay 3X and the builder here was going to pay 2X, if builder 1 did not bid, imagine this is not here, then the auction would have been won by 2X. And X, I don't know, I can make these concrete numbers, but say X is just like an ETH. So say this is 2 ETH and 3 ETH. And the idea then is that, if you want to like draw this out, 2 versus 3, something like this. If this was not here, because this was the second highest bid, then this bid would have won the auction if this builder was not here. When the builder is here, they're obviously going to win the auction, but this in some sense sets like a floor or a ceiling, depending on how you look at it, for the auction itself. And so what this means is that builder 1 could have paid 2.1 ETH, let's say, and won, right? And so that's the intuition here, is that this relay then can basically rebate the builder some amount here. Say now there's like, what is that, 1.9 ETH? That doesn't really need to be paid to the proposer and could just be sort of retained within the relay builder system. And that's what this sort of, I don't even have like a nice name for this, but there's like a rebate function. Builder rebates is probably the best way to describe it. There's a builder rebate thing here where now the relay can say, okay, rather than you paying all of this to the proposer, we can keep some and then split this up between ourselves. It could be like 50 to the relay, 50% to the relay, 50% to the builder. It could be other things, but now you go from having absolutely no revenue in the relay to now having some. I think that's all I'm going to say about that. Oh, question?
Regarding the first price auction, what about like the proposer on like his own relay? So he's only like interacting with only one relay. So yeah. So yeah, the proposer is only interacting with one relay, meaning that the builders are not aware of what the other builder are bidding about the other bids, meaning that we can increase the winner's curse and mainly for integrated builders. So because we don't really know how much are like what are the margins with the 6-6 arbitrages.
Yeah, sorry, what was the question exactly?
So does it make sense like to switch to first price seal auction to increase the rewards? Because in the English auction, like the builders are looking at each other's and they will just outbid at the last, at the end. So if we are moving to a first price seal auction, and we have to suppose that there's only one relay, because I guess it doesn't make sense to have different auctions types between relays. So we have to be sure that there is only one relay. If it's a good way to increase these winners curves, because I think that some market makers really want some blocks,
Yeah.
and they are willing to pay more than what they're actually paying at the moment.
Yeah, it's a good question, and like I guess like the first thing to say is there's again like even just making a small change like this, it like has like pretty big impacts for again bidding strategies and how everyone like shows up to this game. So things need to be changed very thoughtfully. I guess one thing to say here is, yeah, like I think the like key difference that we're talking about right now would just be the fact of whether the bids are like sealed or not. So rather basically they're private. And like one way to think about this implementation wise is, so the bids basically from the builder, like the blocks the builder sends are all sealed in this sense. Like other builders can't see that from the relay, assuming the relay is acting well. But then they expose them all to like anyone. And instead, you could imagine now that the API is like authenticated or something in a way that only the proposer can access them. So already, because of what I just said, you can imagine like builders cut deals with proposers to like sidestep this fact. Like you still need to have the relay talk to the proposer somehow, and you could still then have a side channel. Like a proposer could be malicious in the sense of like still sharing like order flow somehow. You can scope it more tightly to like just the proposer from like this particular slot, and that helps some, but there was a concern there, at least I know that's been discussed before. Another concern is just general observability of the system. Like if we do this, then it's like much harder to know like what builders are even bidding and like how they're acting. So right now there's actually like pretty rich data APIs that all the relays support. And because of that, then they can, not they, but us, everyone, can actually look quite deeply into what's happening. And things like this would get in the way of that. And it might be, good. I'm not saying it necessarily is, but it could be. It's just more that it's an open question, and there are a lot of like dimensions to this. Yeah. Question.
Do you know what are the network performance implications of creating new layers and bringing this on the chain?
Like network performance of ePBS.
Yeah, so I suppose these are happening on the P2P layer, right? Sending the blocks.
Nothing right now. No.
No, not the right now on ePBS.
Well, not even. Yeah. So that's a question. Like I think if anything, ePBS is like somewhat agnostic. Oh, okay. So let's talk about 7732, the IP. So that is, if anything, fairly agnostic to like how bids are produced. You could imagine there's a gossip layer, but the concern then is that again, time is money, and so what will happen is like there's some overhead to gossip, and so bids will propagate more slowly, and then because of that, builders just won't use the system. They'll kind of, we could imagine they very directly go to some more like pipe or point-to-point communications, and this is where you have like proposers directly connecting to builders. Again, just for latency reasons. So yeah, the only case I would see P2P being relevant for ePBS is the case where it's now like an even lower barrier to entry for new builders to enter the scene. And the way this would work is that rather than needing to convince a validator to connect to me directly, I can just kind of have like a almost like open channel where like anyone can send bids, and it's then you have DOS protections and things in place. But then now you can imagine it's much easier for like new builders to enter into the network. Then the question is like, yeah, how valuable are these new players, and how does that all shake out with the other ones? Is there any evidence that the builders' relays are co-located? Good question. So co-location refers to this fact that, right, again, because of how important latency is here, this was referring to the fact that rather than have your builder like halfway around the world from the relay, like let's say there's a relay somewhere in Europe, the builder could be somewhere in like, I don't know, Tokyo. There's not quite like a substantial latency between these two even on the internet. And then the question is like, yeah, well, if time is so important, we could just have them right next door. Like even literally like there's a computer and then there's a computer right below it and they're directly connected together, right? That's very low latency. So when we say colo, this is what we mean, that they are directly connected in this way. Is there any evidence? I think there might have been some research that tries to get into this. I'm not sure if there's anything public because I think it's kind of hard to assess just from public data. I mean, one way you could maybe get about this is like, you know, both builders and relays have APIs exposed, and you could maybe just like ping them directly and try to like geolocate them in a sense. Yeah, POTUS.
At least two relays advertise exactly which servers they are. They have two different servers on two different continents, and they are collocated, and they are under 1 millisecond. No, but under 1 millisecond communication.
But relays or builders? Like, I don't know. I think from
relays advertise where they are, and the builders are collocating with them, and the communications today is under 1 millisecond.
There's a bit more to that because obviously the relay wants to be close to the proposer. So if the relay is closer to the proposer, you can delay things a little bit more as well. So what the relay wants to do is to be in lots of locations that are close to proposers, and the reality is that they want to be close to Lido.
and other validators. But yeah, I mean, I have seen relay designs where they have this like geo distribution baked in, just again to reduce latency to validators. Do relays get paid for doing their task? If no, what are the advantages for someone to run a relay? I'm also going to see how we are on time. Okay, about 30 minutes. So do relays get paid for their task? If no, what are the advantages for someone to run a relay? If yes, do block builders pay them and how? The short answer is no, other than, again, I think the most like public thing we've seen is just this like builder rebate mechanism I was trying to describe. And otherwise, what are the advantages? Yeah, I mean, I think the initial idea was, you know, there are altruistic actors in the space who care about Ethereum and want to like provide this as almost like a public good. And so that's what they do. There have been a number of like funding efforts in the space, like PBS Foundation is one, that tries to like help the situation and like provide at least some like tools for sustainability. And yeah, otherwise, do block builders pay them? Yeah, so yeah, I'm trying to avoid getting into maybe sensitive things, but ultimately, let's just say it, you might imagine that builders are paying for things for special treatment, which, if anything, motivates ePBS, right? Because, you know, we talked about this with the searchers a second ago. Like, you guys, you know, we aren't dumb. Like, we can imagine that there are like things happening with these actors, and if anything, like, the way we remove that is by sort of enforcing more things in the protocol, either with like cryptography, code economics, all of our usual tools, and that really does motivate solutions like, you know, different flavors of ePBS. Trust assumptions. Okay, what are the trust assumptions between builders and searchers? Yeah, so this is an interesting question. Maybe I will say just a little bit about searchers because I think I just threw the term out. There is this vision that there is like I have some slides for this, but it's not a big deal. So ultimately, there was this vision that you would have, again, the like many actors, and it's a very like diverse setup for this transaction supply chain, which is basically saying like, okay, these days we think about intents. So you can imagine I even have an intent. You know, I like want some meme coins, and then I just like yell this at someone on the internet, and then it somehow turns into like a final transaction on some blockchain. And then we ask, how does it go from like, you know, the thought in my head to actually landing on some chain, like a concrete state transition in one of these systems. So there's like a lot of ways to think about this. And again, like I said a bit ago, like every day there's like some new actor or entity that like kind of shows up to the table. But you could imagine that sort of simplified model that's helpful to think about is that there's, you know, myself as a user making a transaction For that, I like use either an application or like a wallet. They then would make a transaction that goes into, say, the mempool. From there, you could have these like specialized entities called searchers, who then are looking at the mempool, and these are the ones now that know these like very sophisticated strategies for MEV extraction. Like a typical one to think about is like sandwiching, where basically if I have a lot of slippage on like a trade I want to make on some DEX, which is basically referring to like my tolerance, let's say, for like execution, meaning I would accept a worse price or maybe a better price than like what I exactly think I'm getting. And in any case, searchers then can basically work around this slippage and kind of take out the bits that you left on the table in terms of having this flexibility of your trade against, say, what's on chain, because then as you realize there's like markets that are moving other places in the world, the chain then like follows them eventually. And point being is there are ways to extract MEV. Searchers are the entity that would do this. Now then, if you have a bunch of searchers in the world, they might want to specialize exactly in these like very sophisticated strategies. They might not be the best at like building blocks themselves, because they are kind of separate tasks, where a builder might have like a bunch of usually like bundles of transactions from searchers. They would then put them all into like a block that's valid with respect to the protocol, and then the builder then would work with proposers via PBS. Okay, so that was long-winded, but ultimately there's this notion of searcher, and if anything, what we've probably seen evolve over the years, that is not good, but we've essentially seen like vertical integration and kind of the dissolution of these different roles. You know, in the limit, like we're talking so much about why latency is so bad, like you could imagine they're like, okay, well, why even have a builder separate from a relay, right? Like they could just be the same thing. And if anything, that also gets to like this co-location question, like this is exactly what happens. So I think similarly, you see various arrangements with searchers and builders. There is a lot of research I know that has gone into this question. If you just search like, probably like, yeah, builder search or vertical integration or something, you'll find plenty of research there. But ultimately, yeah, in an ideal world, you could imagine that it would make sense to have them be separate entities at separate parts of this transaction supply chain, and they might be mutually distrustful. And in that case, yeah, then you need to think about like, okay, how do I make sure that it's really the same set of problems, again, just between builder and searcher, like how do I make sure that the builder is not going to like either search themselves against my order flow, they're going to like, you know, if I have a bundle of transactions that pays me as a searcher some amount, I want to make sure the builder doesn't like mess with that in any way and like respects the, you know, one way to think about this is it is like sensitive data in this context, and so like you just have to be careful who you share things with. And yeah, point being is, I think in practice you see like all sorts of trust assumptions, all the way from like I'm a builder and you can just send me flow, and you know, ultimately it's sort of a just trust me bro arrangement. And if anything, that means then that like you're relying on reputation of the builder, because you know word does get around. Otherwise, yeah, I think you even see things on the other end of the spectrum where like builders basically are searching themselves and being like very active players beyond just like constructing blocks. So yeah, it's a rabbit hole in itself. Let's see, are there any other questions? I think, okay, we still have some time. There's one here. So what are your thoughts on 7732? Do you think it will be implemented? Okay, so 7732 is this EIP I was talking about earlier. That's like a particular construction of a flavor of ePBS. There are other types of flavors of ePBS. You might have heard of like APS, which is like a tester proposer separation. And you know, I think there's been more thought since even like the earlier PBS days around like how we might want this to actually look in the protocol. And because of that, well, yeah, basically because of that, there are different ideas. And yeah, so I don't think it's like super settled that like this is the right or like the only direction to go in. That being said, there is in this sort of bucket of things of having this like PTC, the Payload Timeliness Committee that I called out way at the beginning of my slides. There has, I think, been the most work on like formally specifying this design, and it has gotten us to the place of an EIP 7732. And yeah, so do I think it will be implemented? Well, it already has been. POTUS is back there and has been working on it quite a bit. So maybe talk to him after if you want to hear more about that. But ultimately, yeah. So like there is an EIP, which is a very big step, very exciting to see. And yeah, I mean, there's a number of things in there. Maybe the question is asking like if I think it will be, implemented or included on mainnet. And yeah, I mean, with 7732 in particular, like I think it does start to like, if anything, it iterates us towards these like maybe even more forward-looking designs around like APS. You might have heard of like execution auctions or execution tickets. Again, there's like a whole research zoo of things there. But ultimately, yeah, so that's something that's nice about it is that it sort of sets us up to start moving in that direction with respect to the protocol. Another nice thing that I like, this is like kind of zooming in just one part of it, but it essentially adds this notion of like pipelining to the protocol that actually makes a lot of things more resilient. Right now, sort of the execution layer and the consensus layer are coupled together in a way. And what this means is, for example, if relays go offline, they can't essentially complete the auction exchange, and then there's no block for that slot. This is bad. And one nice thing with 7732 is it does add this like pipelining, which uncouples the execution and the consensus layer blocks. So you'd at least be like somewhat tolerant to this fault with relays, which would be nice. What else about 7732? Yeah, I mean, again, I think POTUS and I could have a bit of a conversation about this, but I'm not as convinced that it will necessarily get rid of the relays today. I do think it will like lower barriers to entry, and we might see new actors enter the market, which is very good. But yeah, I think given all these like latency concerns and just like entrenched infra that we have today, it's like not as clear that even if we have something in the protocol, it's going to necessarily, get rid of or move people away from using the relays they're using today. Question?
Sure. Yeah, I'm just wondering if you have any insight onto like if there's been any changes on like how dApps or like let's say intent networks or other applications are like sending their transactions to builders and like having their transactions show up on chain. Like are exchanges just still sending all of their transactions to like the mempool, or do they do order flow auctions, or are there like other ways that like dApps are evolving and like sending transactions to builders?
Yeah, I mean, I think it's all of the above, and it's like hard to say just because again, there's like new ideas people come up with every day, so like it's hard to keep track of it all. Even one thing recently has been like 437 and this notion of like bundlers, and so now there's like, you can imagine this whole sort of pipeline is now not just for transactions but also for like user ops, and it just kind of like broadens the scope of everything. Then yeah, lately then we've seen like the rise of like intents and solvers, and like again just like either a prefix or even like another way to think about like getting to actual like state transitions on chain, which is like quite interesting. And yeah, I think maybe you touched a bit, or like we're pointing at this notion of like private order flow. So like this is something I think we've seen like a pretty huge growth of. I should have numbers. I don't have exact numbers on the latest data, but basically, yeah, there's been like very much a rise in private order flow, meaning like transactions that never touch the public mempool. If you play this out, one way you could think about it is that we actually get to a place where like there is no use for like the public mempool, which is like very bad for like CR type things, censorship resistance. But it could be the case that, and yeah, so I don't think we'll get to a place where there's like no one using the mempool, but you could get to a case where like 90% of transactions just basically use other methods. And if anything, the mempool serves as like a sort of inclusion pathway of last resort, save for like censorship resistance.
And a little follow-up. I'm just kind of curious, like, how do solvers on like intent networks, like CowSwap or Socket or whatever, like, do they, when they're like creating blocks or partial blocks, like, are they sending them directly to builders, or are they sending them to searchers, or like, where do those intents go, like from like in various intent networks?
Yeah, I think it depends. And like even when we say intent networks, I think there's ideas around like even having things that look like rollups or like other blockchains that are like providing some like infrastructure for intents. But even without thinking about like something like that, you could just have like a bunch of solvers who are like, say like CowSwap for example is a good idea or a good example where they're taking in things that look like intents. They do some work to figure out how to like make the best blocks, and then Yeah, I mean, they would all literally go to builders today. I mean, yeah, they don't have to, but it would be a huge lift for. Well, no, I mean they really do have to, because otherwise you would just gossip. Like, let's say let's like take CalSwap as an example, and you like have this nice like CalSwap partial block, or like say it becomes a full block. You can't put this in the public mempool because then like someone could just steal it, right? So yeah, they really do rely on these like PBS pathways. Yeah.
Thank you. That's really helpful.
Okay. I don't see any other questions, and I've been talking for a while. Okay, POTUS has a question.
Yeah, I'm curious, what are your thoughts on things that are off protocol today and that they're not envisioned to be on protocol, like pre-confirmations and pre-confirmation for L1, pre-confirmation for L2, and that the whole builder system is like building towards that. And I wonder if we act late, we might lose the chance of implementing the endgame auction, either execution tickets or execution auctions or whatever research comes up if we're late.
Yeah, I don't think it'll ever be too late. Like, I don't know, if it is too late, then I would say it's also too late, even with like PBS today and 7732, for example. And like, I just don't really believe, at least, I don't know, I would hope that that's not the case. But it's a good point. Yeah, it could be the case that we do have off-chain systems that basically get so entrenched, it's like very hard to even, yes, we can change the protocol, or like we can, as a community change the protocol, but then the question is like, would it matter, right? And it's just like being sensitive to the fact that like, history is real. We live in a world. And yeah, this is definitely part of the consideration when thinking about different priorities around like research into different topics and things like this. So you mentioned pre-confirmations. This is a very interesting one. Yeah, maybe just like a quick TLDR for the crowd. If you don't know what this is, the idea is that basically, like if you go to use a L2 today, you basically are working directly with like a centralized sequencer. And so, you're like, hey, I want to make this trade on, this Uniswap pool on whatever L2. They can basically immediately say, yes, you're good to go. You're at this part in the block, and tell you that immediately, rather than waiting for the entire L2 block to be ready to be produced. And that's more like what it looks like on L1. So pre-comps here basically are a way to think about this like UX or this set of features at L1. And there's been some designs. There's like a number of like pre-confirmation teams that are working on this to like add this to L1. To be honest, like, yeah, I guess I have mixed feelings because like most of the designs I've seen are basically just copying a lot of this like, they have different labels, but one way to think about this is having like this builder relay proposer architecture, but then there's just like different functions they perform in the pre-conf context. The problem here is that this is all very much centralized, right? Like you would hope to have like, yeah, if anything, you start to decentralize like the relay or the builder in this context. And with pre-confs, they call this like a gateway that you can think of as like a relay. Yeah, I don't love it. People are building it. Ethereum's a permissionless system, so it is what it is. The claim is that we will eventually sort of do this like progressive decentralization over time. So it's not that it's like, this terrible thing that's just going to happen. But definitely I think it's something to keep an eye on and be very, just be very mindful of.
Hi, thank you for doing this. Maybe a more specific question. So looking back like 1 year and how blocks have been constructed back then, the proposer payment was usually the last transaction in the block. And now looking over the last year, especially with Titan Builder growing, we saw a change in pattern there where now they're like sending like a bunch of internal transactions to combine this payment. Do you have any idea why they do this, and is this something why they're so successful? And the second part is, do we actually have like a spec of what kind of things can be included to pay the proposer? Could it be in the next block or whatever? Like, do we have that?
Yeah, these are good questions. So the first question is, yeah, like the way that at least the implementation started with this whole thing was that they were basically expecting the last transaction in the block to pay the proposer. And yeah, but there are other ways you can think about paying the proposer as a builder, and we've seen some of them crop up over time. So, you know, one way that I know people like is actually just having the proposer be the fee recipient in the block, because then you can just call the Coinbase opcode and then pay Coinbase. And yeah, there's a number of reasons to do this. One of them is it's actually just cheaper, like the Coinbase opcode to load and then pay. And then, yeah, I mean, I guess we should double check this, but I would imagine that like, you know, Coinbase in the EVM, call in the EVM is going to be cheaper than this like having a whole other transaction. So it's basically a way to just have like, yeah, more efficient payments. You could also then imagine you have other arrangements, maybe with searchers or different things where you might want a little more flexibility than just this like one fixed transaction. So yeah, there's a lot of reasons to do it, and yeah, there's a number of ways to structure it. In terms of like a spec, there is one actually. I believe, let's see, I think it was just like the last hard fork. This question came up in the context of withdrawals. You can imagine then that if I'm a proposer, so part of the relay working here is that they get blocks from builders, they work with the one proposer to sort of have this auction happen. Part of this right is like verifying the payment is made correctly to the proposer. There's an issue though, because now we have this notion of withdrawals, you know, out of the consensus layer into the execution layer. And that was causing some problems with implementations because they just didn't really have logic to account for withdrawals, and it would lead to like weird reporting. There's like Twitter bots and things that would like flag high MEV blocks, and it would lead to like weird things. So in any case, yeah, I worked with people on like a spec for exactly this. I think, well, okay, I might have lost slide ability, which is okay. But anyway, in any case, there's like a GitHub repo, so GitHub Ethereum builder specs, like builder-specs, and there's essentially like payment schemes specified there. So right now, I believe it's just the like last transaction and then the Coinbase route. If there's others that should be there, let me know. If anything, the idea is like this specifies like honest behavior, and so like one like very popular and sort of like foundational implementation of the relay right now is like under the Flashbots org, and so yeah, like their relay follows the spec, and you know we could add things, but it's should be a bit of a conversation before just like adding a bunch of wild stuff. Does that, I think that answered your questions. Yeah, cool. Okay, I think we have a few more minutes, but if there are no questions,